In this video, we will explain you how to set initial parameters in the program and how to save the data received in the program. You are working with a laser that emits radiation with a wavelength of 727.3 nanometers. Your external environment be water. The angle of incidence is 1.37. And you are working with the following deposited layers of SiO2 and TiO2. You get a structure of some type. We look at the step 2 how it looks. Now we choose the optimal number of layers. In this case it is 6. And you work with this structure. Next time you want to see the dispersion with more points. And you want to work with this structure again next time. But if you exit the program and start the program, then you must set the initial parameters that you need once again. That is, you must again set the same parameters as last time, which is rather boring and tedious. To somehow simplify this process, the program has a configuration file in which you can set the initial parameters that appear after starting the program by default. To do this, we go to the program's configuration file and change the data here to those that you plan to use most often in the near future. Change the wavelength to 727.3 nanometers. Angle at 1.37. And let the number of points along the axis in the dispersion pattern will be doubled. We also change these data for the refractive indices of the double layer. Our external environment is water now. And we change the number of layers to 6. We save this data and run the program with new initial parameters. We see that we have a new wavelength, a new incident angle and a new external environment. When we move to the second step, we see that we have 6 layers here. That is, we immediately get the optimal structure with which we want to work now. And when we look at the dispersion, we see that our number of points has increased. So, now we want to change something in this structure and it becomes differ from the initial one. By some intuition, we put here a different thickness of this layer. Now we get such a splitting of the dispersion curve. If we want to save this new data for the future, then we have several options how to do this. First, we can save it as a text ASCII file. He's already saved with that name. We see that we have a new directory, here it is. We can also print our structure by printing it as a PDF file. And, most importantly, we can save it as a table, and we be able to load this table directly into the program next time. This bin file will also be kept in the same directory, here is its name, 6 layers from May 2nd. When we run this program again, we can immediately go to the step 2, no matter with what parameters, and load this table there. And, as you can see, the thickness of this layer has changed. Indeed, if we look at the dispersion again, we will see that this is the dispersion of the structure that we saved as the bin file. Among other things, the dispersion image can be saved as a PNG file, or as a MAT file. This MAT file can be opened in MATLAB with this command from this auxiliary text file. If we copy its contents to MATLAB, then we will immediately get a visualization of the data stored in this MAT file. Here is the same picture of the splitted dispersion curve, which can now be studied in MATLAB or prepared for publication. And the last but not the least possibility of the program is next. The first 3 lines from this configuration file can be rewritten not only through configuration file, but also via 3 parameters after the exe file. That is the wavelength, angle, and the number of dispersion points may be pointed here without rewriting the configuration file. For example, here we type 821.2 as the wavelength, 1.34 as the angle, and 900 points for the dispersion image. Now we see that we really have changed the initial wavelength and the initial angle. And in step 2, if we will calculate the dispersion, then the total number of points in the image will be 900 squared. That's all for now. Bye.